Okay, today we're going to look at something called weighted voting. So this is typically in a corporate shareholders meeting. Each shareholder's vote counts proportional to the amount of shares they own. An individual with one share gets the equivalent of one vote, while someone with 100 shares would get the equivalent of 100 votes. This is called weighting voting. Each vote has some weight attached to it. Each individual or entity casting a vote is called a player in the election. They're often notated as P1, P2, P3, and so on. Each player is given a weight, which usually represents how many votes they get. The quota is the minimum weight needed for the votes, or weight needed for the proposal to be approved. A weighted voting system will often be represented in the shorthand form Q colon W1, W2, W3, and so on. In this form, Q is the quota, W1 is the weight for player 1, and so on. So in a small company, there are 4 shareholders. Mr. Smith has 30% ownership stake in the company. Mr. Garcia has 25% stake. Ms. Hughes has 25% stake. And Ms. Lee has a 20% stake. They're trying to decide whether to open a new location. The company bylaws state that more than 50% of the ownership has to approve any decision like this. This could be represented by the weighted voting system. The quota would be 51, which is more than half of the 50, or of the 100. And then here's the 4 weights of the 4 players. The limits on the quota. The quota must be more than 1/2 the total number of votes, which makes sense. You have to have a majority to win, at least. The quota can't be larger than the total number of votes. How can you get more than the number of votes available? Okay, I do not like this example. So let's continue on. A player will be a dictator if their weight is equal to or greater than the quota. The dictator can also block any proposal from happening. The other players cannot reach quota without the dictator. A player has veto power if their support is necessary for the quota to be reached. It is possible for more than one player to have veto power, or for no player to have veto power. And a player is a dummy if their vote is never essential for a group to reach quota. So let's look at a voting system here. We have a quota of 16. We have player 1 with a weight of 7, player 2 with a weight of 6, player 3 with a weight of 3, player 4 with a weight of 3, and player 5 with a weight of 2. So the first thing to look at, are there any dictators? Is there anybody that will have 16 votes by themselves? And of course, no. So there are no dictators. And what about veto power? So the way to look at this is, let's see if player 1 has veto power. Can the vote pass without player 1? So if everybody else votes for it, you have 6 plus 3 plus 3 plus 2, which gives us 14. So player 1 does have veto power. It cannot pass without player 2. Now let's look at player 3, or player 2, I mean. So if player 1 agrees and everybody else but player 2 agrees, we have 7 plus 3 plus 3 plus 2, which is 15. And again, it can't pass, so we have to have player 2. So what about player 3? Well, let's see. If player 1 agrees, and player 2 agrees, and player 4 agrees, and player 5 agrees, we have 18 and it passes. So player 3 is not a dictator, or player 3 does not have veto power. Player 4 likewise would not have veto power because it's the same number of votes. And since player 5 has even less votes, it would not have veto power either. Now, what about dummies? Well, since player 1 and player 2 have veto power, they cannot be dummies. It cannot pass without them. So they are necessary. However, if we look at player 1, player 2, and player 3, well, it passes. So player 4 and 5 are not needed. Likewise, if we have player 4, player 3 and 2 are not needed. However, they can be necessary. However, let's look at player 1, which is 7, and player 2, which is 6, and player 5, which is 2. That does not pass. So in order for it to pass, we have to have either player 3 or player 4. And if we have player 3 or 4, player 5 doesn't matter either way. So player 5's vote does not matter, whether they vote yay or nay. Okay, we're looking at another example. In the voting system, Q1053, which players are dictators, which have veto power, and which are dummies. We're going to start with Q is 10. Okay, we need 10 votes, so we have a dictator of player 1. We have veto power. Player 1 has 10, so player 1 also will have veto power. And since it can pass with just player 1, player 2, or player 3 does not matter. Now, are there any dummies? Well, let's see. Essentially, we've determined it cannot pass without player 1. But it can pass without player 2. Doesn't matter what he does. If player 1 votes for it, it's there. If not, it's not there. So player 2 is a dummy. Likewise, player 3. Doesn't matter what he'll do. Still going to be the same. Now, with a quota of 12, we have a dictator. And no, we don't. Nobody has a power of 12. How about veto power? Well, if player 2 and player 3 vote for it, that gives them a total of 8. So it cannot pass without player 1. Now, how about a dummy? Well, we know player 1 is necessary. Now, if player 2 votes for it, and if player 1 and player 2 vote for it, it passes. If player 1 and player 3 vote for it, it passes. So there are no dummies in this case. Player 1 cannot do it by himself, but need either player 2 or player 3. Therefore, it does matter how they vote. And then let's look at 16. Here we have a dictator. That's definitely a no. Nobody has the power of 16. How about veto power? Again, it's not going to pass without player 1. And what about actually, I have a mistake here. Go back to that in a minute. How about a dummy? Oh, that's right. Never mind. And there are no dummies again because it matters. If player 1 passes and player 2 doesn't, player 3 can affect it, whether or not he does or doesn't. Likewise with player 2. So there is no dummy there as well. Okay, so now we're going to talk about coalitions. If you watch any political news, you probably hear all about coalitions. As far as this coalition or that coalition. We won't go into the different ones, just realize that this is part of where that comes from. Coalition is any group of players voting the same way. Coalition is a winning coalition if the coalition has enough weight to meet quota. A player is critical in a coalition if them leaving the coalition would change it from a winning coalition to a losing coalition. So let's look at this. In Scottish Parliament in 2009, there were 5 political parties, 47 representatives for the Scottish National Party, 46 for the Labour Party, 17 for the Conservative Party, 16 for the Liberal Democrats, and 2 for the Scottish Green Party. Typically, all representatives from a party vote as blocks, so the parliament can be treated like weighted voting system. And we have a quota of 65, then we have the numbers representing the different weights for the different parties. Consider coalition P1, P3, and P4. So P1, P3, and P4. No 2 players alone could meet the quota. These 2 would be 64. These 2 would be 63. These 2 would be 33. So there's no way any 2 of them could meet. So all 3 of the players are critical to the coalition. If any of them drop out, it is no longer meeting it. Okay, now let's look at the coalition P1, P3, P4, and P5. So let's see what happens here. Essentially, what it says is any player at select P1 can leave, and the coalition would still meet quota. So if P2 were to leave, we would still have 65, which is enough. If P3 left, we would still have 66, which is enough. And if P4 left, or P5 left, sorry, we would still have 80, which would be enough. So P1 is critical in this coalition. The others are not. So we're looking again at dictators, veto dummies, and critical players. A player is a dictator if the single player coalition containing them is a winning coalition. A player has veto power if they are critical in every winning coalition. And a player is a dummy if they are not critical in any winning coalition. So now we're looking at coalition as being the player. So we come up with something called the Banshee Power Index. To calculate the Banshee Power Index, list all the winning coalitions. And each coalition identify the players who are critical. Count up how many times each player is critical. Convert these counts to fractions or decimals by dividing by the total number of times any player is critical. So let's look at our power index for this voting system. First step, list all the winning coalitions. Now P1, P2 would give us 9. And P1, P3 would give us 8. P2, P3 would give us nothing. So, next, in each coalition, identify the players who are critical. Well, in all the, oh, there is one more. P1, P2, P3. So in this coalition here, both of them are critical. It will not pass. If player 2 drops out, we'll only have 6 and it won't pass. Likewise with player 1. Same here, they're both critical. However, here, the only critical player is player 1. Because if player 3 drops out, we still have a winning coalition. If player 2 drops out, we still have a winning coalition. Count up how many times each player is critical. So player 1 is critical 3 times. Player 2 is critical once. Player 3 is critical once. Now convert these counts to fractions by dividing by the total times any player is critical, which is 5. So the power index for this is 3/5, 1/5, and 1/5. Okay, another voting system. Find the power index. So let's see. You can have player 1, player 2, and player 3. That gives us 16. You have player 1, player 2, player 4. That will give us 16 as well. Likewise, we could have player 1, player 2, player 3, player 4. And player 1, player 2, player 3, player 5. Those all meet. Winning coalitions. We could have player 1, player 2, player 4, player 5. And of course, player 1, player 2, player 3, player 4, player 5. We have any more winning coalitions? And I think that is all of them. So in this first case, it adds up to a total of 16, so all of them are critical. Player 2, player 3. Same here, player 1, player 2, player 4. Okay, now here, we need 16. So we have to have player 1, have to have player 2. But if player 3 drops out, we still have 16. Or if player 4 drops out, we still have 16. So only those two are critical. Here, player 1 and player 2 are critical. And what happens if player 3 drops out? If player 3 drops out, we only have 15. So we need player 3 as well. But we do not need player 5. Same thing here. We need player 1 and player 2. If player 4 drops out, we only have 15. So we need player 4, but we don't need player 5. And same here, we need player 1 and player 2. But if player 3 drops out, we still have it. If player 4 drops out, we still have it. If player 5 drops out, we still have it. So that is all. Now let's see. We have 3, 6, 8, 11, 14, 16. Okay, player 1, player 2, player 3, player 4, and player 5. 5 is easy, 0 over 16. Player 4, there's 1 and 2. 2 over 16. Player 3, we have 1 and 2. 2 over 16, and player 2, 1, 2, 3, 4, 5, 6. And player 1 is also 6. And that is our power index. Okay, let's see. Another example. So player 1 and player 2 will meet the criteria. That'll pass, 37. Player 1 and player 3 will pass as well, with 36. Player 2 and player 3 won't. Player 1 and 4, 2 and 4, and 3 and 4 will not. Okay, so now player 1 and player 2 and player 3 will work. Doesn't matter, either way. And player 1, player 2, and player 4 will work. Likewise, player 1 and player 3 and player 4 will work. And of course, player 1, player 2, player 3, and player 4 will work. So in the case of this, both of them are necessary to pass. Player 1 drops, we only have 17. If player 2 drops, we only have 20. Doesn't work. Same principle here. So both of these are critical. Now in the case of this, if player 2 drops out, we still have 36. And if player 3 drops out, we still have 37. So only player 1 is essential there. Okay. This one here, player 1 and player 2 make 37. So player 4 doesn't matter. If player 2 drops out, we don't have enough. So player 1 and player 2. This one's going to work out exactly the same. Player 1 and player 3. And in this case, it's just player 1 again. So we have 2, 4, 5, 7, 9, 10. Player 1, player 2, player 3, player 4, player 5. Player 5 is 10, 0 out of 10. Player 4 was not, player 4, not 5. I'm counting too many players. So player 4 is critical in 0 out of 10. Player 3 is 1, 2 out of 10. Player 2 is 1, 2 out of 10. And player 1 is 6 out of 10. And just as a side thing, to check that you've got this right, if you add them all up, we get 10 over 10, which is 1. Okay, the next idea we have is something called a sequential coalition. A sequential coalition lists players in the order in which they join the coalition. The pivotal player is the player in a sequential coalition that changes a coalition from a losing coalition to a winning one. Notice there can only be one pivotal player in any sequential coalition. So we have our weighted voting system with a quota of 8. Player 1 has a weight of 6, player 2 a weight of 4, player 3 a weight of 3, and player 2 a weight, or player 4 a weight of 2. So we're looking at this coalition, and I'm going to write it bigger here. Player 3, player 2, player 4, player 1. And it's denoted as a coalition using these marks here. So let's write out the weights of these so we can see it easier. 3, 4, 6. Oh, that's not 6, that's 2. 2 and 6. So now let's look. When player 1 votes, we have 3 votes. Not enough to win, so he's not pivotal. Player 2 adds their votes. We have 7. Still not enough to win. Player 4 adds their votes. 2. Now we have 9. So essentially, player 4 is the pivotal player. Even though he has the fewest or lowest weight, he is the pivotal player. Okay, now we're going to look at another power index called the Shapley-Shubick power index. To calculate the Shapley-Shubick power index, list all the sequential coalitions. And each sequential coalition determine the pivotal player count up how many times each player is pivotal and convert these counts to fractions or decimals. So, how many sequential coalitions will there be in a voting system with 7 players? Now, if you're taking MGF 1106, you know that is simply 7 factorial, which is equivalent to 7 times 6 times 5 times 4 times 3 times 2 times 1. Because order does matter. It's 5,040. Needless to say, that's a whole lot. And we'd have to list them all. So here we have, consider the weighted voting system, list all the sequential coalitions, and identify the pivotal player. So first we need to list all these coalitions. We're going to player 1, player 2, player 3. We're going to player 1 and player 2. And player 1 and player 3. We could have player 2 and player 1. You can have player 3 and player 1. Have player 2 and player 3. And we could have player 3 and player 2. And we could have player 1, player 2, player 3, player 1, player 3, player 2, player 2, player 3, player 1, player 2, player 1, player 3, player 3, player 1, player 2, player 3, player 1, player 2, player 1. 3, 4, 6, 2, 4. Okay. These are all our possible coalitions. Okay, first off, no individual is going to meet it. So here, player 1, 4, player 3, player 2 passes. Same thing here. Here, the second one is always the pivotal player. And same deal here. No. Player 2, player 3 will not pass. Player 2, player 3 will not pass. Player 3, player 2 will not pass. That only give me 5. So here, player 1, player 2 is pivotal. Player 1, player 3 is pivotal. Player 2, player 3 would give us 5, so player 1 is pivotal. Player 2, player 1 is pivotal. Player 3, player 1 is pivotal. Player 3, player 2, player 1 is pivotal. Oops. Wait a minute, where is it? So, determine the pivotal player. We did that. Count how many times each player is pivotal. I have P1, P2, and P3. There's 1, 2, 3, 4, 5, 6. Player 2, 1, 2, 2, and player 3, 1, 2. Okay. And then we divide. There's 10 total. So this is 6 out of 10, 2 out of 10, 2 out of 10, which again adds up to 1. No. 10 over 10 or 1. Okay, I'm not going to do another one of these. That would be done the exact same way. We need to look at another one. We can do it in a separate lecture. And that is the last one. You guys have a good day. And I will we'll talk to you next time.